All right, so just a quick review of the four methods. So the first thing I wanted to go over is the easier one. Hamilton's method is actually the simplest and most straightforward. It uses a standard divisor to calculate standard quotas, rounds each quota down, and then gives any remaining seats one by one to states who have the higher decimal values. Jefferson, Webster's, and the Hill-Huntington methods all use modified divisors. And trial and error to find the correct divisor to achieve the correct apportionment. So you're always trying to get that total of the rounded values to add up to the total number of seats you want. Each method varies of Jefferson, Webster's, and Hill-Huntington's in terms of how they get rid of the decimal in the quotas. Jefferson's method truncates the decimal. Truncates is a way of mentioning that you chop it off. You just eliminate the decimal. Webster's method uses standard rounding rules. And then the Hill-Huntington method uses what's called geometric mean rounding. To eliminate the decimal. So the question you might ask yourself is that we've used four different methods in the history of our country. Is there a best method? Well, it turns out there is not. It was proven by some people, Belinsky and Young, that no apportionment method is fair in all cases. Now, notice, is fair in all cases. It certainly can be fair in a specific case, but for all cases, that would be for every single situation, every single population and number of states you could think of. It is not possible to find a single method for dealing with that decimal that would be fair for everyone in every single situation. So you basically want to do the best you can. And what people have done with computers is investigate these methods more closely and looked at how often they would violate certain rules like the quota rule. And what they find is the Webster and Hill-Huntington method will only violate the quota rule about once every 200 apportionments, whereas Jefferson's would violate it quite frequently. So at least we're using a method currently, the Hill-Huntington method, that violates the quota rule a little bit less. So that's the best you can do, is try to be fair in most of the time, even though you may not be able to be fair all of the time.